Hello everyone, and welcome to our channel. Today, we're diving deep into the planet we call home, Earth. It's easy to take our world for granted, but the more we learn about it, the more we realize how truly remarkable it is. We've prepared top 10 fascinating facts about Earth that might surprise you, impress you, or simply remind you how amazing our planet is. So sit back, relax, hit that like button, subscribe to our channel if you haven't already, and share this video with your fellow Earth lovers. Let's begin! Earth is around 4.54 billion years old. One of the first questions many people ask is, how old is Earth? Through radiometric dating of meteorites and Earth's oldest minerals, scientists estimate our planet to be around 4.54 billion years old. That's an enormous span of time, giving Earth countless opportunities to change and evolve. Early formation. Earth started out as a molten planet, bombarded by asteroids and smaller protoplanets in the young solar system. Differentiation. Heavy elements like iron and nickel sank to form Earth's core, while lighter material formed the crust. Cooling and oceans. As Earth cooled, water vapor condensed to form oceans, which would later become cradles for the earliest known life. Understanding Earth's age helps us piece together its ancient geologic past and the long timeline in which life arose. Each chapter in Earth's story, from the Hadean Eon of extreme volcanism to the present Anthropocene, reveals an ongoing narrative of transformation and adaptation. Earth isn't a perfect sphere. We might commonly visualize Earth as a perfect blue and green sphere, but in reality, it's slightly flattened at the poles and bulged at the equator. This shape is called a geoid or oblate spheroid rotation effect. Because Earth spins on its axis once every approximately 24 hours, centrifugal force pushes out slightly at the equator, causing the bulge. Polar flattening. The polar radius is about 6,357 kilometers, while the equatorial radius is about 6,378 km, a difference of roughly 21 kilometers. Gravitational variation. This shape affects Earth's gravitational field, meaning gravity isn't perfectly uniform around the planet. Though the difference is not colossal to the naked eye, it's significant enough for satellites, geophysicists, and cartographers who measure Earth with high precision. This oblate shape influences everything from sea level calculations to the orbits of spacecraft. Earth's atmosphere, a thin layer that enables life. One of the most critical reasons life exists on Earth at all is our atmosphere. By cosmic standards, this atmosphere is incredibly thin. Just a blanket of gas hugging the surface for roughly 100 kilometers if we consider the Kármán line as the boundary of space. Yet this tenuous layer is vital. Composition: about 78% nitrogen, 21% oxygen, plus argon, carbon dioxide, and other trace gases. Protective shield: the atmosphere deflects harmful solar radiation, particularly UV, and burns up countless meteoroids that would otherwise strike the surface. Climate regulation: by trapping heat, the greenhouse effect, it keeps temperatures stable enough for liquid water to persist, and water is key to life as we know it. If Earth had no atmosphere, we'd face extreme temperature swings between day and night, lethal cosmic radiation, and zero breathable air. Essentially, our planet would be a barren rock, not the vibrant biosphere we inhabit. About 70% of Earth's surface is covered by water. Earth is sometimes referred to as the blue planet, and for good reason. Roughly 70% of its surface is covered by oceans, seas, lakes, and rivers. Water is the fundamental resource that supports ecosystems worldwide. Salt water: about 97% of Earth's water is in the oceans, salty and undrinkable without desalination. Fresh water: only approximately 3% is fresh water, locked mostly in glaciers, ice caps, and underground aquifers. Accessible fresh water is a small fraction but crucial for human use. Climate influence: oceans store and distribute heat around the planet, driving weather patterns and regulating global climate. This abundance of water has made Earth uniquely hospitable to life. Yet fresh, potable water is a precious resource that requires careful management, especially as populations grow and climates shift. Plate tectonics: Earth's surface is in constant motion. Unlike many bodies in the solar system that appear geologically static, Earth's crust is not a single unbroken shell. Instead, it is divided into multiple tectonic plates that float on the semi-fluid upper mantle. Movement speed. Plates shift at an average rate of a few centimeters per year, comparable to the pace at which fingernails grow. Boundaries. At plate boundaries, we see mountain building, for example the Himalayas, volcanic activity, for example the Ring of Fire, and earthquakes. Renewal and recycling. New crust forms at mid-ocean ridges, while older crust can be subducted back into the mantle at convergent boundaries. Plate tectonics plays a huge role in Earth's habitability by regulating volcanic outgassing, recycling carbon, and shaping continents over geologic timescales. These shifting plates have rearranged Earth's continents multiple times, from supercontinents like Pangaea to our modern distribution. Earth's magnetic field, a shield against solar radiation. Earth's strong magnetic field is generated deep within its liquid outer core, primarily by the motion of molten iron and nickel, the dynamo effect. This magnetic field extends into space, forming the magnetosphere, which deflects solar wind. A barrage of charged particles streaming from the sun is mostly redirected around Earth, safeguarding our atmosphere from harsh erosion. Auroras. Interactions of charged particles with Earth's upper atmosphere near the poles create aurora borealis, northern lights, and aurora australis, southern lights. Navigation. Early explorers relied on Earth's magnetic field for compass-based navigation, which remains crucial even in today's GPS era. Without this magnetosphere, our planet's surface would be hammered by far more dangerous cosmic radiation, potentially stripping away our atmosphere and making life far more difficult, or impossible. Earth is the only known planet with life. So far. In decades of searching, scientists have yet to find definitive evidence of life anywhere beyond Earth's boundaries. While Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are prime candidates in our solar system, as of now, Earth remains the only place where we know life thrives. Key factors contribute to Earth's livability. Habitable zone. Earth orbits the sun at just the right distance where water can exist as a stable liquid. Liquid water. Water is essential for biochemical processes common to known life forms. Atmosphere and oxygen. Our air is not only protective but also oxygen-rich, supporting respiration for a myriad of organisms. Active geology. Plate tectonics helps recycle nutrients, supports diverse habitats, and maintains a dynamic, ever-changing environment conducive to evolution. While there may be billions of other habitable worlds in the universe, Earth is the only confirmed cradle of life, so far. It's precisely this rarity that encourages us to protect and cherish our home. Rotation and revolution, day, night, and the seasons, Earth has two fundamental movements. Rotation around its axis. Every 24 hours, roughly, Earth completes a spin, giving us the day-night cycle. Revolution around the sun. Earth takes about 365.25 days to orbit the sun once, which leads to the yearly cycle of seasons. One crucial detail is that Earth's axis is tilted by about 23.5 degrees. Because of this tilt, seasons. Different hemispheres receive varying amounts of sunlight over the year, causing the seasons. When the northern hemisphere is tilted toward the sun, it experiences summer while the southern hemisphere has winter, and vice versa. Equinoxes and solstices. At equinoxes, day and night are nearly the same length worldwide. At solstices, one hemisphere experiences its longest day, summer solstice, while the other its shortest, winter solstice. Without this axial tilt, Earth's climate would be far more uniform, drastically affecting biodiversity and the evolution of life. The interplay of rotation, revolution, and tilt shapes nearly every aspect of our planetary climate rhythms. Extreme temperatures and habitats. Despite being a relatively moderate planet by cosmic standards, Earth's surface harbors some extreme environments. Coldest places. Antarctica can reach below -80 degrees Celsius in the winter. The coldest recorded temperature on Earth's surface is about -89.2 degrees Celsius at the Vostok Station in Antarctica. Hottest regions, deserts like Death Valley in California or the Danakil Depression in Ethiopia can see temperatures above 50 degrees Celsius. The highest reliably recorded temperature is around 56.7 degrees Celsius, Death Valley. Deep ocean trenches. The Mariana Trench in the Pacific, with depths over 11,000 meters, is under extreme pressure and near freezing water, but still sustains specialized life forms. High mountains. The Himalayas, Mount Everest rising to 8,848 m, or the Andes present thin air, cold weather, and intense solar radiation. From scorching deserts to icy poles, from humid rainforests to lofty mountaintops, Earth's variety of habitats is astounding, and life has found ways to adapt to nearly all of them. Earth is constantly changing, and lastly, it's important to realize that Earth is not static. Natural forces and human activities combine to shape our planet. Climate change. Greenhouse gases, deforestation, and pollution alter weather patterns, sea levels, and biodiversity. Tectonic shifts. Continents move slowly, affecting oceans, climates, and eventually the distribution of flora and fauna. Extinctions and evolution. Over millions of years, Earth has witnessed 5 major mass extinctions and multiple evolutionary radiations, evidence of a planet always in flux. Conservation and sustainability. Our modern challenge involves balancing development with the planet's health, ensuring resources and stable ecosystems for future generations. We inhabit only a fleeting chapter of Earth's long story, yet our global impact is considerable. Understanding Earth's dynamic nature is critical for preserving the ecosystems we depend on. Conclusion: those were our top 10 fascinating facts about Earth. Let's quickly recap what we've covered. 4.54 billion years old. Earth's geological timeline spans billions of years. Oblate spheroid, slightly flattened at the poles due to rotation. Atmosphere, a thin but life-giving shield of gases. 70% water coverage. Oceans dominate the surface, regulating climate and enabling life. Plate tectonics. Continents move, mountains rise, and earthquakes occur in a constant cycle of renewal. Magnetic field shields us from harmful cosmic radiation, enabling life. Unique biosphere. Earth remains the only confirmed planet with life. Rotation and revolution. Day-night cycles and seasons shape our everyday existence. Temperature extremes. From Arctic cold to desert heat, Earth's biodiversity thrives in many niches. Ceaseless change, climate shifts, tectonic activity, and human influence ensure Earth is always evolving. We hope these highlights inspire you to appreciate the complexity and grandeur of our blue planet. If you enjoyed this deep dive, be sure to subscribe to our channel, and share the video with friends and family who care about science and our world. Also, let us know in the comments which fact amazed you the most, or if there's anything else you'd love to learn about Earth. Thank you so much for watching and being part of our community. Stay curious, and we'll see you next time as we explore more wonders of our universe.